Now let's start part 4 of this examination preparation paper, and this one has a difficulty level of 2 again, so it's a little bit more intensive than the ones in part 1. So let's get started. Question 27. Okay, you can see that a fraction equals to a fraction, can't you? Whenever I see a fraction equals to a fraction, I always like to do some cross multiplication. Okay, and I've explained why in the preparation paper 1, so if you don't really understand, I advise you to watch the first one first. So let's do some cross multiplication. So I'm going to multiply this with this and this with this, just like this. So 6x minus 1 times 2x plus 3 on this side, and 4x plus 1 times 3x minus 4 on this side. Okay, and just expand it all out. So this will be 6x times 2x, which is 12x squared, 6x times 3, which is 18x, negative 1 times 2x, which is negative 2x, and negative 1 times 3, which is negative 3. 4x times 3x, which is 12x squared, 4x minus 4 equals to negative 16x, 1 times 3x, which is 3x, and 1 times negative 4, which is negative 4. Just some expansion here, guys. And now I need to gather the like terms. So here 18x minus 2x is 16x, and negative 16x plus 3x is negative 13x. Now further, let's gather the like terms, and I know that the 12x squared would cancel each other out because of the same, and if I move negative 13x onto this side, I'll have 16x plus 13x, which is 29x. And move the negative 3 over to this side, I'll have negative 4 plus 3, which is negative 1. So x is just negative 1 on 29. Okay, so hope the cross multiplication made it a lot easier to expand and simplify, right? That was question 27. 28. Okay, again we've got some fractions, but this time we have an inequality. So this time I'm going to multiply both sides by 6 to eliminate out that fraction, because see how the denominators, the lowest common multiple actually is 6. So I'm going to multiply out by 6. So it's going to be 6 divided by 3, which is 2, and 6 divided by 2, which is 3. Okay? And sorry if I said highest common multiple in the other questions. I'm pretty sure I meant lowest common multiple, so make sure you correct yourself on that one if I did say highest common multiple. It should be lowest common multiple when you're multiplying out to eliminate the denominators, right? Sorry if I did say that. But anyway, let's continue. So 2 times x plus 2 on this side, and 3 times 3x plus left on this side. So expand it out. So I've just expanded it. I won't go through why. And then gather your like terms. So if I move the 9x over to this side, 2x minus 9x is negative 7x, and 3 plus 4 is 7. Now divide both sides by negative 7, so x is going to be greater or equal to negative 1. And see how I switch the sign there, guys? Because I'm dividing by a negative. Make sure you always switch the sign if you're dividing or multiplying by a negative number. That's the answer though, so very simple. 29, okay, absolute value questions. So we know that whatever we absolute is going to be positive. So even if it's a negative number, if I put absolute bars around it, it's going to turn out positive. So I know that the inside here, that can be positive or negative. So 2x minus 1 could be positive 5, or 2x minus 1 could be negative 5. So we're going to solve two separate equations. So solve them individually. Move the 1 over, so 2x equals to 6. Divide by 2, so x equals to 3. Now this side, move the 1 over, so 2x is negative 4. Divide by 2, so x is negative 2. So two solutions, the final answers are x equals to 3 and negative 2. That's it. So that was pretty simple, wasn't it? Just remember that there's two different cases you must consider, okay? Two different cases. One's positive, one's negative. So question 30 is very similar to the previous question, but this time we have two absolute bars. Okay, so both sides have absolute bars surrounding them. Now, I want you to think of it as similar to what we did in the previous question. Now, x minus 1 could be negative and 2 minus 3x could be negative as well, or both could be positive, or only one of them could be negative. All cases are possible because of the absolute bars. No matter what the signs are, it's all going to turn out positive. Now, what I'm going to do to this one is only think about two cases. One which is both positive, the other one which is x minus 1 is positive, but this one is negative. So negative, which is expanded to this. Or you can say that this is negative, x minus 1 is negative, and this one is positive. So you can solve this one or this one. Both will get you the same answer, so you can choose whatever you like. Alright? Now, before I continue, the reason why I'm only considering these two cases is because I'm considering both positive case, which is that one, and here I'm considering only one is positive. So this is positive, or you can say this is positive, and I told you that both can get you the same answer. Now, the reason why I'm not considering when both is negative is because when both is negative, the negative signs on both sides will just eliminate, eventually making it the same as this, positive. So there's no point in having the negative negative. Okay, so basically guys, eventually you only have to consider just these two cases. Okay, so it's actually the same as the previous question. So now all I need to do is solve them individually. So this one, just solve it guys. I have 4x equals to 3. Divide by 4 to get x equals to 3 on 4. Here, same thing. I have negative 2x equals to negative 1. The negatives will cancel out, and therefore x is just 1 on 2. So therefore the final solutions are just 3 on 4 and a half. And that's it. So just treat it the same way as we did in the previous question. Okay, so that was question 30. 31. Alright, we want to simplify these fractions, so basically I want to make it into a single fraction. To do that, I want you to factorize the denominators. So here the common factor is x, here the common factor is 2. And you can see after I've done that, x plus 4 is both common. It's common for both, which is good. But you can see that here we have an x, but we don't have that 2. And here we have a 2, but we don't have that x. So in order to make it the same, I should multiply this fraction by 2 on top and bottom. So now, and here I should multiply by x on top and bottom. So times by x on top and bottom. So the denominators will then be the same. So I have 2 times 2, which is 4, and 1 times x, which is x, and now the denominators are same. They both involve 2 and x plus 4. So now that we've made the denominators the same, leave the denominator as it is and just simply add the numerators just like this. So now we can see that 4 plus x is the same as x plus 4, isn't it? It's the same thing, although the arrangements are a little bit different. So I can cancel these out. So the answer is simply 1 on 2x, and that's it. So that's good that it cancelled out. Now it looks a lot more simple, doesn't it? So that's how I've simplified that. So always when you're simplifying fractions like this, make it into a single fraction first. Okay, I want to solve this equation in simplest exact form. Now, for the reason why I'm saying simplest exact form, I think it's because it probably won't factorize and we'll have to now depend on the quadratic formula, because it is a quadratic equation, and you can see that 2, the only factors are 1 and 2, but there's no way we can make 2 with 1 and 2, right? So we'll have to use the quadratic equation, quadratic formula, sorry. So we're going to just go straight to the formula. It's going to be minus b, so minus minus 2, plus or minus b squared minus 4ac, so b squared, 2 squared, minus 4, a which is 1, c which is negative 2 over 2 times 1. Okay, just simplify inside the square root for me. It's going to be, if you simplify this one, it's simply going to be 12. Hopefully I don't have to explain how that happened. Now you can see that root 12, it's 4 times 3, isn't it? So root 4 is going to be 2, so the 2 can pop out the front and only the root 3 remains. And you can see 2, 2 and 2, they're all divisible by 2, so they all become 1. So the answer is simply negative 1 plus or minus 1 root 3, or just root 3. Okay, and that's the answer, guys. So I want you to leave it like this in exact form. Okay, exact form. Okay, and I've simplified it as much as possible, so that's your final answer. Now part B is asking us to solve that equation corrected 2 decimal places. So I've got the third form for that one, or the exact form, but now because they wanted to round it up in 2 decimal places, put that in your calculator individually. So put -1 plus root 3 and -1 minus root 3 individually into your calculator and see what you get. You should get those two values, and I'm sure you guys all know how to round it to 2 decimal places. So for this question, I just want you to try it by yourself and just check for your answers with mine. Okay, so that's the answer. It's a very simple question, just using the formula. Now 33 says sketch absolute value of y equals to 2. Okay, which means that y could be +2 or -2, because even if it's negative, because of that absolute bars, it will just turn out positive. So I'm going to say that y can be plus or minus 2. So therefore, it has 2 horizontal lines, one which is +2 and one which is -2. Okay, and that's it. Both lines are part of that graph. Okay, and that's it, guys. So that's the answers to question 33. Now 34, sketch absolute value of y equals to x. Now for this question, I want you to try and ignore that absolute value, ignore the absolute bars for a moment, and just sketch y equals to x first of all, which is your basic linear graph, just that one passing through the origin, right? Now I want you to convert all the negative x values to the positive side, because we want x to be positive. Y could be negative, but the outcome of this side must be positive because of that absolute bars, right? So x must be positive. But see how this part of the graph, guys, indicates negative values for x, because the values on the right side of the y-axis is the positive values of x, and on the left it's the negative values of x. So this side is negative, but because of the absolute bars it's going to turn out positive. We simply use y-axis as a mirror and reflect it to the positive side. So just like that. So this side is reflected to the positive side. So y-axis is the mirror. Okay, so therefore the yellow graph there is the answer to this question, is the graph of the absolute value of y equals to x. Okay, so pretty simple, guys. And that's it, that's question 34. And that concludes this part as well.